Hello, everybody. Welcome back for a new episode of the Midnight Sessions. We're going to follow the same procedure for those that are joining live. We have at the end of the session an option to answer some questions, have some discussions. So you can write your questions on the chat, or I'm gonna provide a hand feature here in Discord that you can raise your hands and you can join the stage and we can have a discussion. But this is gonna happen at the end of the episode. The first 45 minutes, we're gonna be talking about ecosystem, tooling, coding, and then I'm gonna open for questions and answers. Okay, perfect. This episode it's full of really nice material. We are getting more into the code itself and testing, and also start discussing other topics, not only to dApps, but also the infrastructure that supports the Midnight network. Okay, so we're going to start taking a look at a blog hosted by Steve, which is one of the developers of the DevRel team. And he put this blog, how to become a Midnight blog producer on testnet. So if we open this blog, we get this information. So we're gonna go through this material and we're gonna analyze where are more detailed information for those that want to start building on Midnight as an operator, a Midnight blog producer. So they say here, Midnight blog producers play an essential role in the Midnight ecosystem by generating and validating new blocks to ensure the security, resilience, and integrity of the blockchains. The more participants and the more resources that are deployed towards consensus and block production, the higher the overall resilience and security of the system. So this is something really important for blockchains when it comes to consensus. We need the one of the main features of a blockchain is decentralization. So as more producers, more block producers are part of the network, you're gonna have more security and resilience. To learn more about Midnight block production and incentives, read the tokenomics. So within the tokenomics, they explain how these block producers are gonna be rewarded, and that's an important topic as well, because it's not only important to have a infrastructure that is decentralized, but actually to motivate people to host those nodes, this software, they have to be incentivized. And the way normally blockchains do that, it's by their tokenomics. And that's something that we have reviewed in the past when we were looking at the tokenomics and the white paper of Midnight. This article outlines and connects you to the essential resources, including key information and documentation to help you get started as block producer on Midnight Testnet 02. So this again, we are in the Midnight Testnet 02. It was an improvement that happened on the infrastructure that it make it more efficient when it comes to resources, and also way much faster to respond under events. So Steve, he's besides this blog information for those that have time during the weekend, and I really recommend you guys going through this material. He provided this YouTube series where he explains everything, how to become a blog producer with videos. So if we go to Midnight, we can see here the Midnight YouTube channel. They have this series hosted by Steve, where there is 16 episodes, really short episodes. If you see here, it's normally 55 seconds, 3 minutes, 2 minutes. So it's really quick. You can go through all these material under 1 hour and a half. And well, this is kind of a walkthrough to actually all the implementation, all the codes to become a blog producer. But now we're gonna see a summary of this procedure. So first, let's understand the infrastructure. To run a Midnight node on testnet, you will need to install the following: a Cardano stake pool operator on preview testnet. right now the Midnight infrastructure it's depending on SPOs in Cardano running on the preview testnet. When it comes to when we enter the mainnet phase, of course, the SPOs in Cardano's they're gonna be running on mainnet as well. So a Cardano SPO. Midnight is a partner chain to Cardano, which means Cardano SPOs can become Midnight block producers, and Midnight block producers will first need to have an SPO on the Cardano test. So it's reciprocal. If you're a Midnight SPO, that means that you are also a Cardano SPO. You cannot be a Midnight SPO by its own, right? You have to be connected. So that's where we, Midnight, have our security from the Cardano SPOs running Ouroboros and gaining all these decentralization that Cardano has. A Midnight testnet O2 block producer is an SPO that has opted into Midnight block production and also runs a Midnight node. So Midnight is the first partner chain of Cardano. In the future, running based on the partner chain framework, we want to have more partner chains, not only Midnight. We might have 10, 20, 30, 50 partner chains. And the Cardano SPOs, they have to opt into those partner chains because it involves running infrastructure, right? So there's cost. So what happens is that, for example, an SPO could say, okay, I want to host these partner chains, Midnight and this other one. So they have to opt into that. Partner chain dependency services. Tools like Cardano DB Sync, Postgres, Kupo, and Ocmios are critical. All these components are included in the Docker Compose project that orchestrates the partner chain dependencies. So that's something really nice for SPOs. Right now, what's available is Docker containers, where you can orchestrate all these implementation using Docker Compose. So it's really easy to implement. And they have mentioned here the different services that the Midnight SPOs will have to host. And then we're going to see this diagram where they connect all these pieces together. And we're going to understand also what is Cardano DB Sync, what is Progress, what is Kupo, what is Ocmios. A Midnight node. A Midnight node is software that connects with the Midnight blockchain. It maintains a copy of the ledger, validates transactions, and runs as a block producer for Midnight testnet O2. Okay, something that they mentioned here is that at least it's recommended a internet connection of its speeds at least 50 megabytes per second. Okay, so this is the setup process. This diagram here in the block is really small. So just to provide some context, this is a summary of the procedure. If you want a more detailed procedure under the Midnight documentation, you're gonna see that we have all these segments. We have a segment for learning, for building. This comes for DApp developers that we want to do applications, but also we have a validate segment. This is everything related to SPOs, running an SPO, how to connect to Cardano, etc. So under this validate, we can see that we have a become a Midnight block producer. So in this first one, we can see this diagram, and let me find the diagram here. So here it's a little bit bigger, I think. So just not sure if you can see this clearly, but I'm gonna explain the flow. In this first part, they mention SPO. Then here it says Midnight node, Ocmios, Cardano DB Sync, and Midnight network. So how this flow is gonna work? You see that for being a Midnight node block producer, you have to be also an SPO in Cardano. This is actually the hardest part, being an SPO. I'm not talking only about infrastructure. I'm talking about delegation, because This is the way blockchain works. You need to have infrastructure, and for creating a block, it's gonna depend on how much delegation you have. So your probability is gonna increase based on your delegation. So you need to have some amount of delegation. In Cardano, if you have at least 3 million ADAs delegated, you're gonna be able to produce blocks every epoch. So if you have that, you have 90% of the path complete. It's really easy to become a midnight block producer. It just depends on the willing of the SPO to become a midnight producer, because it's going to involve increasing their infrastructure, all these instances. So let's assume that you already have an SPO and you have delegation. What comes next? You have to be a midnight node. For running all these instances, we mentioned that we have a Docker Compose to actually spin up and orchestrate all this communication. So the midnight node, it's the one responsible for actually validating the transactions, minting the blocks, and maintaining a copy of the ledger. What is Ocmios? Ocmios is a lightweight bridge to actually talk with the Cardano blockchain using different languages. So Ocmios is used by the midnight node to actually talk with some smart contracts deployed on Cardano. The Cardano network and the committee smart contracts. This is part of the partner chains framework, and this is how all this works, right? Because at the end, what we mentioned before is that midnight, it's getting some security from Cardano, right? But how this happens, how we get the security from Cardano, is because Ouroboros is going to select the committee that is going to be responsible for minting the blocks within midnight. So this is what these committee smart contracts in Cardano will play out. So SPOs, they will have to register as they have to register their SPOs and the willingness to be part of this committee. And then Ouroboros is going to select some of those parties that will actually mint the blocks in midnight. So this is how the security translates from Cardano to midnight. We have also Cardano DB Sync. Cardano DB Sync is responsible for syncing and indexing the information that we have in Cardano in a database for reading information. So what happens is that in midnight, we're going to have to, the node in midnight, they're going to have to see what are the committees, what is the state of this smart contract. And how do we do that? It's by looking at a database. And how do we sync that database is by using Cardano DB Sync. Excellent. So we know how we connect all these instances. A really nice information here for those that are willing to become a midnight, and something that we mentioned, it's we have to be willing to increase our infrastructure. Here they mention the prerequisites here. Depending on the network that you're running, for example, for testing, you might be interested on using testnet, but when you want to start actually minting blocks, you're gonna have to be mainnet. And then here they mention the different resources that you need to host the different instances. For example, Cardano DB Sync, Cardano Node, Postgres, Midnight Node, and Ocmios, right? Perfect. Okay, going back here to the block, we were mentioning how the flow happens within the instances. Then they say here, to complete this effectively, it is recommended to have proficiency in setting up, running, and monitoring blockchain nodes consistently, along with a strong grasp of command line interface, usage, system administration, and networking. And well, every SPO, they have these features and capabilities. To begin, you must operate an SPO, as we mentioned, on the Cardano Preview testnet. If you're an experienced SPO, deploy your SPO to Preview. You need to have an UTXO and its associated payment signing key. This is actually for paying for the transaction that is going to take place when subscribing to the smart contract. the SPO called signing key. This is the way you're gonna demonstrate that you are the owner of that Cardano SPO. If you're new to SPO, refer to Midnight documentation. So this is all this information that I mentioned. That here's a detailed procedure how to be an SPO. Second, set up partner chain dependency services. This is all that list that I just mentioned. With your SPO ready, the next step is to configure dependency services for the Midnight testnet 02. To simplify this process, you can use a Docker Compose file to start the required services on the server. Okay, so what happens next? You have to register your SPO as an MPB. What is that? After setup, you can register your SPO as a committee candidate using the open source partner chain CLI. So there is a repository that you download, and then you have a CLI. And using Octnews, you're going to be able to send commands to the smart contracts to register as a committee candidate. This process is a 3-step sequence which is streamlined with the Midnight Node CLI wizard. Initiate registration, prepare registration signature, and submit registration. Committee rotation. So this is really important, right? Because at the end, okay, everybody can register as a committee, but who are the members from that committee that are actually going to mint the blocks in Midnight? So rotation, how it's going to work. Once an SPO registers as an MNB candidate, then they will participate in the committee rotation in N+2 Cardano epochs. This works pretty similar how in Cardano works. Whenever somebody registers on a SPO to receive delegations, once you have registered, you have to wait for N+2 Cardano epochs. Remembering that every epoch in Cardano it's 5 days, where N is the epoch the registration was submitted. At this point, you will be registered as a candidate in the validator committee. You can verify your registration and committee status using the provided RPC endpoints or by querying the committee for the relevant epoch. And then once you have all that, it just you just have to run your Midnight node, run in the Midnight node. Once your dependency services are operational and the SPO is as a candidate, it's time to run the Midnight nodes in validator mode. This node follows the partner chain scripts for testnet 02, the preview chain, and then you start producing blocks. So see, it's quite straightforward. We already have a lot of candidates registered on the smart contract. So yeah, Midnight is gonna be really decentralized and secure by Cardano. Really happy about that. So anybody that wants to become a block producer, it's really easy, really straightforward. And if you're already at Cardano SPO, you have 90% of the path completed. Perfect. So this about the Midnight block producer and testnet. Now let's start with the next material, which is regarding the Dev Diaries and the Academy. The diary that we're gonna take a look now, it's a diary hosted by, we're gonna open here just to make sure, here. Hosted by Samantha. She's also part of the DevRel team, and she's making a series of diaries, really nice to watch and read, because she's gonna make videos as well, where she explains her process to learn Midnight and blockchain as a whole. She came from a Web2 world, so now she's getting into Web3, and she's putting in these diaries everything that she's learning, right? So it's really nice to see, because you get to understand how people coming from Web2 to Web3, they understand blockchain. So that's really important actually for teaching and embarking people into Web3. So in this diary, she mentions one of two concepts really important in blockchain, and she wanted to share her knowledge. It's about Merkle trees and DAOs, and I'm sure that everybody has heard about these concepts. So let's take a look at them and understand. Okay, So regarding the Merkle trees, let's see here what she says. Merkle trees, ensuring data integrity. A Merkle tree, also known as a hash tree, it's a data structure that enables efficient and secure verification of large data sets. At its core, it is a special kind of binary tree, a structure many Web2 developers will recognize. In a binary tree, each node has at most two children. What makes Merkle trees different is that instead of storing value directly, they store hashes. So you can think of a Merkle tree as a tree of nodes, and each node is a hash. And what is important, what is a feature that we get from these Merkle trees, it's that data integrity. These hashes represent data blocks and provide a compact, tamper-evident summary of all the data in the tree. Merkle trees are crucial in blockchain because they allow a large set of data, like thousands of transactions, to be verified efficiently and securely. So you can see here, this is really important. And actually, that's how some ledgers in some blockchains are structured in Merkle trees. And CSwap, for example, we have already seen that in previous episodes. One of the data structures that we have are Merkle trees with hashes that are the commitments. Instead of needing to check every transaction, you only need a small subset of hashes called Merkle proof to confirm that a transaction is part of a block. Here's a simplified breakdown of a Merkle tree. It starts with data blocks, like a transaction in a block. Each data block is hashed individually. These hashes become the leaf nodes. Pairs of leaf hashes are then hashed together to form the next level of the tree. And this process continues, combining hashes pairwise and moving up the tree until you are left with a single root hash, right? Often called the Merkle root. Okay, so in practice, Merkle trees are used in what use cases? Blockchain transactions, ensuring that transactions within a block are untampered, and proof of reserves. Cryptocurrency exchanges use Merkle tree to prove they hold sufficient assets to cover user deposits without revealing individual account balances. So you can see you can demonstrate things without actually disclosing that information or even saying, I have seen this. We're going to see in a little bit how all this connected with Midnight. DAOs, redefining organizational governance. So what is a DAO? It's a decentralized autonomous organization. So here the key concepts that we need to understand, it's, okay, organization, it's a common concept, but what it means for it to be decentralized, what it means for it to be autonomous. So DAOs are organizations governed by smart contracts on the blockchain. So this smart contract, it's where the autonomous come from. Eliminating the need for centralized leadership, they replace traditional top-down leadership with transparent, community-driven governance, all enforced through code. Why through code? Because it's a smart contract. In a DAO, rules and operations are programmed upfront and stored on-chain. That means anyone can inspect how decisions are made, how funds are allocated, and how proposals are handled. Everything transparent within a smart contract. Everything is transparent and auditable by default. Instead of a single CEO or board, decisions are made collectively by the community. Token holders can vote on proposals, and the outcome reflects the weight of their stake in the project. Okay, here's one of the drawbacks. However, DAOs also face challenges, including security risk. Vulnerabilities in smart contracts can be exploited. Governance issues, low voter participation, and token concentration. Huge issues if the blockchain or the DAO is not structured in the correct way. for those coming from Cardano, we know how this governance took place, and it's actually a DAO. It's the biggest DAO ever, right? Where people, depending on their delegation and participation, they can decide decisions on a blockchain. And it's really important how decentralized is a token. Imagine that based on delegation, you decide things, but only one holder actually represents 95% of the market cap of that blockchain. Is that centralized? Is it decentralized? Right? So yeah, it's important, this token concentration and also voter participation, right? Imagine you have your DAO really decentralized, but only 1% of the community actually participate in the process. Is it centralized, decentralized, right? So yeah, you need participation and concentration, and don't have token concentration. DAOs have been utilized in various domains, such as investment funds, or charitable organizations, protocol governance, for example, Cardano governance. Okay, and here they mention one of the key features: how DAOs voting works, the simple version. Members hold a governance token, a proposal is submitted, token holders vote, and if a certain threshold is reached, that action passes, right? Cardano has that process. Midnight, we're gonna have a governance process as well in the future, and the token that's gonna represent that utility, that governance utility, is gonna be Night. Okay, and here at the bottom, they mention something really interesting: how these two concepts work together. How can we represent something as a DAO and use Merkle trees? And for that, I wanted to share one of the informations provided in the docs. So if we open here in the docs, under build, how Midnight works, we have this: how to keep data private. So here they provide an example how voting could work in private using Merkle trees. So let's take a look at the structure of this compact contract. So first, we're defining two ledger variables called items and others. Items, it's a of type set of fields, and other, it's a Merkle tree. In compact, we represent a data structure as a Merkle tree as Merkle. So it's a Merkle tree of 10 levels of field. So for each of these data types, we have some methods. So for those that don't remember how to see these methods, I'm gonna show you here really quick how to know what are the data types in compact and what are the methods. For that, if you're in the Midnight web page, you go under docs, and then you have validate. You enter under build. You have here the reference and documentation, and you have here the compact language documentation. So here you can see that we have these ledger data types, and we can see here all the data types that we have in compact so far. As new versions comes in, new data types might become available. So right now we wanted to see, for example, we're using the set data type, and we're using the Merkle tree. Where is the Merkle tree? Here, we're using the Merkle tree data type. And here beneath this Merkle tree, we can see what are the different methods. For example, Merkle tree, we can see here that we have check root method, insert method, insert hash method, and so on, right? And all these specifications and parameters. Excellent. So we are using the set and Merkle tree data types. And for the items, the set data type, we have the insert method to insert a new value. And we in the set data type, we can check if we are a member of that data set. And for others, we also have, which is a Merkle tree, we have this method called insert. Perfect. So we mentioned that Merkle trees, the elements itself, the nodes, are hashes. So we need to have a way to create a hash base of a value. For that, we have these persistent hash and persistent commit functions within Compact. So here at the end, they show here a code where you can see here that we have a function that in Compact we call it a circuit public key, right? This public key, we're gonna get a secret key of type bytes, 32 bytes, it's a binary, and we're gonna have a binary output. And we're gonna run this function persistent hash. These functions are coming from this Compact standard library. We have some functions provided by the Midnight team that we can use in Compact. One of those is the persistent hash. So we are creating the hash of a value of type vector, which has two values of type bytes 32, and we're just passing these. We're creating this path, right? This is a vector of this type. The one of the values, it's actually this path, and the other one is this secret key. The secret key is already of type bytes 32, so we're okay. And for this text, this string, we want for it to be also bytes 32. So we're using this function path to convert that string to a byte string of that length 32. So we use path 32 length of what text, some domain separator. So we're creating the hash of this information here. So now with the public key, which creates a hash, in the function increment, we can see here that we are calling that function public key, and we are passing the secret key, which is of type witness, right? So we have a ledger variables, we have a witness, and we have circuits. We have already studied those commands in the past, but just to provide a quick summary, this witness type is for our oracles. The ledger, it's for the state that is going to be held in the blockchain, and the functions called circuits are actually the way that we're going to create our proof to interact with the blockchain and actually change the state depending on the logic within each circuit. So excellent. For the increment circuit, we're actually creating the hash of our secret key coming from our oracle, right? And then we're gonna assert. The assertion, it's this circuit is only gonna pass if that assertion complies. So what needs to happen? It's the organizer, which is a variable, a ledger variable type bytes 32. This organizer, it's gonna have to be equal to the hash of the secret key. If that happens, okay, I'm gonna increment that value. This is of type counter, and the type counter has a method called increment. So what I'm doing here is just comparing, making sure that somebody is that person by comparing the hash, and if that happens, then I'm gonna let that people to increment a value. Okay, so this is okay, but it's still I'm not using Merkle trees. So how can I change this function so we can have the benefits of a Merkle tree? What is that benefit? To actually do some action without revealing who is doing that action. Because in this case, we know that this hash is doing that, right? We don't know who that person is, but we know that that hash it's actually doing something. With Merkle tree, we're going to be able to allow that person to do something without revealing who is doing what. So that's really important. So here, they start putting the Merkle tree variable under the witness, right? The witness is going to have the Merkle tree path, and in the ledger, we're going to have the Merkle tree. So how Merkle trees works? It's we have to how do we demonstrate that we are a member of that Merkle tree? By demonstrating that we know the path to that node. And that's why our witness is of type Merkle tree path. And in the ledger, we have the actual Merkle tree. Perfect. So in this case, we have a function called insert, and we just items is of Merkle tree. We insert the item, and the item it's a hash, right? And then here, this is the witness function. So this is not compact. This is what we're gonna implement on the JavaScript code that we have in our local logic contract codes. I'm sorry, and this is how we calculate that Merkle path that we're gonna pass then as a oracle to the compact contract. So at the end, this is the final code that we have. We can see that we are using Merkle trees, we're using sets, and we're using a counter, and we're using hashes. So how is this gonna work? We're gonna allow a member of this Merkle tree. So, okay, you're the organizer, you can do that. Let's say that we have 5 organizers. So if you're a member, you can actually vote, and nobody's gonna know that you actually voted, but you can demonstrate that you have voted. So it's crazy, but that's something that we can do with Merkle tree. And then they are using this set data type to actually add extra feature that it's really nice and that we have in SysSwap, where we put the nullifiers. They act as a nullifier. So at the end, what we're gonna be able to do with this contract here, we're gonna have members that are gonna be represented on a Merkle tree, and each of those members are gonna be able to vote without anybody knowing who actually voted to and when, but still be able to create constraints like, okay, only one person can vote once. So if you have already voted, you cannot vote again, but none of the members could know what are the members that have already voted. So yeah, incredible features that you are able to do with Midnight and Merkle trees data types. So, and the contract is really simple. You can see that we are just using Merkle trees, sets that represent nullifiers, hashing, and the logic itself. Really straightforward. Perfect. So that's regarding Merkle trees and DAOs. Really simple concepts, but can solve really nice issues and implement, for example, private voting. Now, for the academy, I have seen that these 2 topics were really, we went really in depth. So what I'm gonna do, since we have already been talking 35 minutes, this academy and the hackathons and the catalog, we're gonna discuss it in the next session, or maybe at the end if we have some time, extra time. But now I'm gonna pass to the code section, where we're gonna continue of the coding, and now we're gonna demonstrate how a transaction works. So perfect. Let's go to the IDE. So this is the repository that we're working right now to test our contracts. It's under the Mesh organization. The code, the repository is called midnight.meshjs.dev, and we have already studied the structure of it when it comes to the contract part and the CLI part. And the CLI part, the last session, we finished studying all the functions, all the implementations to have a TUI. So now, in this episode, we are actually going to run the TUI under 2 modes, the standalone mode and the testnet mode. And we're going to see the procedure, how much time it takes to create the transactions, what are the outputs that we get by running those transactions, what are the parameters, how the parameters are downloaded within the circuits. So let's take a look. If we go to the repository, we have to be under this counter CLI, under this folder, counter CLI. So make sure when you are testing, you are under the midnight server template counter CLI folder. Excellent. To know what are the commands that I can run on this repository, we can go to the package JSON, and we see here that we have these two commands: testnet remote proof server and standalone. So this is the two commands I'm going to run. I mentioned that we're going to run as a standalone, meaning all the instances are going to be hosted by myself, and I'm going to run the contract as a testnet remote proof server. What that means that the node and indexer are going to be hosted by somebody else in the cloud, pointing to the testnet network, and the proof server are going to be hosted and running in my machine using Docker. So first, let's run the command standalone. Let's see here the code for running actually this. We're going to run the docker compose command, which is docker, and we're going to get the standalone YAML. This standalone YAML is here, and what we have here is actually the configuration to spin up 3 instances. What are those instances? The proof server, the indexer, and the node. Excellent. So we're gonna pull this configuration YAML using docker compose, and then I'm gonna run a code using node experimental specify resolution equal to node. This makes sure that we can run ESM like code. Loader ts node ESM, and we're gonna run this file. What this makes possible, it's we are used to actually build our code and then run it with node. By building, normally we store the output of the compilation here in this folder, but in this case we are not gonna compile it. We are gonna run it just in time, right away. We are not gonna build. We are gonna build it and run it without storing anything under this. That's why we're using this loader ts node. Excellent. And we are not run this folder source standalone ts. So in the last episodes, we mentioned that we have these entry points. So in this case, we have this standalone. We're gonna run this. We have already this. If this information is new for you, you can go to the last episodes where we mentioned how this works, right? So here basically we are grabbing the information from the standalone. Excellent. So now let's run it. So for that, we're gonna run this command standalone. So before running anything, you have to make sure that you have 3 instances configured and running. One is Docker, right? In this case, I'm using WSL, and I have Docker desktop. If you're using Linux or other operating system, just install Docker and make sure that it's linked to your IDE. How you make sure that everything is connected? You can just run Docker version, and if you have a version by running that command, that means that your Docker it's installed. Then another thing that you need to make sure that you have is your compiler, right? So for Midnight, we have compact. So let's see, we have compact C version. So we can see here that we have version 0.24, which is the latest version of compact. And then of course node version, and we have node. Perfect. If you have all those packages, you are good to go. Of course, if you are just downloading this package, you're gonna need to build the contract and compile it, right? In the previous episodes, we learned how to do that. In this case, we already have it compiled. How can you know if you have that? Is you go to this contract folder under source. You're gonna have this dist folder and this manage folder that we have all the output after compiling our contract. If you have that information, perfect. Okay, so let's run our contract using the standalone mode. So it's standalone. npm run standalone, right? So we run it. We are pulling those 3 instances: the indexer, the node, and the proof server. And then we are just waiting for those instances to download, right? If we take a look here at the Docker desktop, we can see here that we have these instances installed. Or if we download, I'm sorry. So if we have these 3 instances, we can see that we have those 3 instances running: the nodes, the indexer, and the proof server. Something really nice to see, and we're going to be discussing that in the future as well. If we take a look at the files of the proof server, we can see the logs here. So right now you can see here that it's downloading a lot of parameters. You can see here public parameters K12, K13, K14, K15. We have fetching public parameters for cswap. So here, this is the login. How we can see those files? If we go to files under cache, we can see that under the midnight folder, we have CK params. This is how we build circuits, right? We need parameters for that CK framework that we're using, in this case, Hello 2. So under CK parameters, we can see that we have some parameters for Kashina and some parameters for cswap. For Kashina, we actually get the public parameters up to K15. We can download K16, 17, but in this case, the proof server is just downloading up to the until the parameters K15. And for cswap, we get these parameters. You can see here that for cswap, we actually have the end results parameters, which are the prover verifiers CK IRs. We have already seen that information. So for those that are kind of thinking, where have I seen this kind of information before? If we go back to our code, we can see here that under the output of the contract, we have keys and CK IRs. So this is specific for a circuit based on public parameters. For cswap, we already have that implementation. So it's already a kind of a specific circuit, let's call it that way. cswap, we already have that logic implemented. In Kashina, we have the public parameters, but we still need to implement the logic for our contracts to get this final information. Don't worry, we are downloading all this information, which is public, the public cryptographic material. Perfect. So we have the logs, we have downloaded successfully. So now we can see here that after running the commands, we know that the first process that we're gonna do, it's actually get a wallet, right? In a standalone, we use a specific address to initialize our wallet, where we get funds right away. We don't have to talk with a faucet to request some funds. We just specify what is the wallet that we want to use, and right after spinning up the instances, we're gonna have funds under that wallet. So excellent. So let's analyze here the logging that we have after initializing that wallet. We can see here that the file path, okay, the wallet seed is 000 and ends with 1. This is the seed of the wallet that we have to use. We can use other seeds, but of course we're not gonna get any funds from that wallet. We have to use this number 1. And then we have the wallet address, and our balance is 0. We don't have anything. And since we're using this seed phrase, which is 1, we're gonna actually receive funds. So we are here waiting for the funds, and then we are receiving the funds. So in this case, we have 25 billion dust. Excellent. And then we have some logs from our wallet. In this case, we're saying, okay, this is the address, right? This is beige 32M. We have already studied that in previous episodes. We have the available coins. This is all information that we get from our wallet. What are the available coins? we have an object, an array of different elements represented in this object, where what is this? This is actually a qualified coin info, which represents a coin. And what are the elements? Then we have an index that represents a position within the Merkle tree. We have a nonce. This is how we demonstrate that we are the owner of that token. The type, which represents what is the type of that token, right? We have, for example, dust, and we're gonna have other tokens. So each of those tokens have a type and then a value. So we can see here, for example, comparing. This type ends with 0, 0, and this one with 0, 2, and this one with 0, 0. So these two here, this one and this one, are the same tokens because we have the same type. The nonce are always different because it represents a different commitment. The index as well different because it's positioned in different part of the Merkle tree. And we have a specific one. Then we have another type of 2, and then we have 0, 0, 0. This 0, 0, this one that ends with 0, 0, it's actually the dust token. Then we have balances. So this is the summary of all these commitments, right? So you can think of it as a UTXO. For those that are coming from Cardano, CSwap works pretty much like UTXO, but with a privacy feature added on. Okay, so the balances, we have this type, we have this type, and we have this type, and these are the balances. We have our coin public key, and this is the coins that we have. In this case, the coins and the available coins are the same. We know that we have in our wallet, we can see that our coins as coins, available coins, and pending coins. We have already studied that in the past, in the previous episode. So we have balances, coins. What else? The encryption public key, we know that addresses, we have coin public key, encryption public key. So we have our encryption public key here, and we have nullifiers. So there is a nullifier for each of those commitments of qualified coin info. So let's make sure that it's correct. It should be correct, but let's check. We have how many nullifiers? 1, 2, 3, 4, 5, 6, 7. If we see here how many coins we have, it's 1, 2, 3, 4, 5, 6, 7. So for each coin, qualified coin info, we have a nullifier associated to that qualified coin. Pending coins, we don't have any. And the progress of our wallet, it's 0, 0, means it's synchronized. It's synchronized between our front end and the back end, and the back end to the blockchain itself, the indexer. And the results sync through. Excellent. So we have our wallet, we have funds. So now what we can do, here it says, you can do one of the following: deploy a new contract or join an existing contract. In our case, we don't have any contract, so we're gonna deploy a new contract. We're gonna deploy. So now what's gonna happen? We are actually gonna create a proof, and we're gonna send that proof to the blockchain, and the node is gonna verify our proof against a verifying key. And if that's okay, the states are gonna be updated, the indexer is gonna be updated, and we're gonna get our result back. So in this case, it's processing. We are gonna analyze the output of these. Sorry, where is? Okay, so we run it, right? We can see here that the deploy contract, and the contract address is this one here. So this is our contract address. If we go to the proof server Docker, we can see here that in my case, it's gonna depend a lot in your local machine resources, how much time it takes for the instance, the proof server instance, to actually generate the proof. In my case, it took almost 12 seconds. So we generated the proof, and we have our contract address back, which is this one. Now with the contract, and I have joined the contract, I can do the following. I can increment, which is the only circuit that we have in our contract, or we can display the counter value. We know that the initial, I'm sorry, we know that the initial value of our counter is 0. So if we select the option number 2, we can see the actual value of our counter. So we can see here that the value right now is 0. So let's increment it by 1. For that, we have to run the increment circuit. So if we choose option number 1, increment is going to run that circuit. So again, every time that we run a circuit, we have to create a proof. So if we go to the instance of the Docker, we see here that the proof server received a request and it has already created a proof, generated a proof. This time it took 7.2 seconds. So we see here that we got the response back. So the response, we can see here that we receive a transaction hash, a transaction ID, a block height, block hash, and we have a public transcript. This is something that we have already studied before as well. If this is new to you, you can go to previous episodes. And the public transcript is basically the program and the actions that we're gonna run within the blockchain. So if we here at the end, we can see that in a transaction in Midnight, we can divide it with things that have to pass or optionally pass. For example, here we have these guaranteed effects. This is something that it has to pass for the transaction to succeed. So we have, every time that we run a contract, we have the effects part that are claim contract calls, claim modifiers, claim receives, claim spends, and mints. In this case, since we are not altering any token state, all this is empty. We are just updating a state on the ledger. The gas of that transaction is represented by this number, and then we have this program, right? The program, it's the logic, the code that is going to run after our proof is accepted by our node. So a transcript, it's composed by this stuff. We have effects, we have the gas, and we have our program. This program, it's for those that have seen some information in the Midnight docs. The language that is run in the node itself is called impact, and the language that we use to create contract is called compact. Okay, so we have here the program, which is with impact code, opcodes. Then we have the fallible effects. So we mentioned, right, we have code that has to pass and things that could fail and is still our transaction pass. So this is under the fallible effects. And again, we have, in this case, we don't have any. And then we have our private section that we have the inputs of our circuit, new coins. In this case, it's 0 because we are not using any coins. We have our next private state. We are not changing anything with private state so far in this contract. And we have the next CSwap local state. Again, it's not changing anything because we are not changing any coin in CSwap. We have the output of the circuit and the unproven transaction. Excellent. So we can see that we are connecting all the terminology and concept that we learned before, and we can see that we get those values after running the circuit. So now, after running that circuit, we can again increment one more time, or we can display the current value. Since we have already incremented the value by 1, if we run option number 2, we should see 1 as our value of the contract. So let's take a look. So if we choose option number 2, we can see that now our ledger state is 1. Perfect. So we have gone through all the process of a transaction. In the next episode, we're gonna keep going through this academy part and hackathons and catalog. There is a lot of material, so this is the part 1 of this episode. In the next week, we're gonna go through part 2. And regarding to code, we're gonna finish the second part as well. Now we run everything as a standalone mode. In the next episode, we're gonna run it as a under testnet mode. Excellent. So now I'm gonna open. I'm gonna see here if anybody has any questions. I'm gonna enable the options to request to speak if somebody wants to join the stage. In case anybody has any questions. I'm gonna check here. Okay, but let's see here if in the okay, so somebody wrote me how to initialize this repository. So as I mentioned, this is the repository under the mesh organization, and to install it, you have to git clone this repo, and then you have to build the contract here in the control contract. You go here to the package.json. So here you can see that you have commands to actually build and to compile your contract. And after having done that, you just go to the control CLI and run the commands that I just showed you, right? And making sure that you have those three instances, right? Docker, you have the compact install, and you have nodes. Again, all that process was shown before on previous episodes. So those that kind of got lost in the process because there are some concepts that were not explained, I would recommend to start with episodes 1, where we start from the beginning, understanding the different concepts, what are the instances, how to install them, and then we keep going through up to now episode 12 that we are reviewing this. So every episode, it could be watched by its own, but in case you are missing some concepts, are getting lost in the process, I would recommend going back to 8, 7, 6, depending on your knowledge. But again, maybe in episode 13, 14, 15, we might re-study some topics because they changed. In the Midnight ecosystem, everything is changing constantly. New instances are being created. New versions of the compact language is being changed. The syntaxes. So we have to keep updating the information provided. Okay, so here John's. Okay, Stark Ada here wants to join the stage. Okay, I'm gonna invite to speak.
GM, can you hear me?
Yep, perfectly.
Hey, yeah, no, I appreciate. This is the first time I'm tuning in, and it's a good review. I appreciate you doing these. I want to go back and listen to your other streams, and I think I definitely want to review this one. I had some questions, some general questions about Midnight. I don't know if you know the answer. You might. I'm looking. I'm seeing if I can get some answers. Anyways, I'll just go ahead. As far as like partner chains goes, I'm trying to understand how Midnight is a partner chain. And I feel like I've come up with a analogy. If you can just confirm, Midnight and Cardano are married, i.e., that they are partners. But if Solana or these other Doge, like something like Dogecoin or Bitcoin, if they implement the partner chain framework, right, they become partners to Midnight in the same way that Cardano is. So the analogy I used is that Midnight and Cardano are married, but Midnight can also get married to Bitcoin and Solana. So it's like a man and his wife, but then the man has more wives, essentially.
Yeah. Well, actually, the marriage can be broken, right? Right now, Midnight depends on Cardano, but in the future, if that's something that Midnight decides, they can break that marriage, right? Because this is part of the partner change framework, and then with Minitor we're gonna be able to add different consensus options, right? So in Cardano we have this smart contract that Oroboto selects what is the member of part of the committee that it's actually created block in Midnight, but that decision can come from other blockchains, for example, Ethereum, Bitcoin, whatever, right? And and then with Minitor, we're gonna be able to say, okay, I want that decision to weight 25% based on Cardano, 25% based on the consensus in Ethereum, and then Bitcoin. And in the future, if Midnight then decides, okay, I don't want Bitcoin anymore, they can decide, okay, to take that committee out of the part of their decisions. And something really nice that they mentioned is this creates a lot of flexibility to actually uh, kind of accept permission members. For example, a country that is governed by a central bank and some commercial banks, and they before they were just running based on those five entities, but now let's say they want to control 60% of the power of the blockchain, but increase their security by joining a public blockchain as Cardano. So they don't lose their power, their decision making by controlling 60% of the stake of the power of the consensus, but increase their security by giving 40% to, for example, Cardano. So now, regarding the marriage, that's something that it's really nice. I'm really in favor of that because I'm come from Cardano. I support a lot Cardano, and I think it's the best blockchain for security and decentralization. So it's something that Midnight is really interested, but it's not blocked into it. It's not locked into that marriage. So as long as Cardano provides the best feature and base security ever, there's no reason why Midnight they would want to break that merge in the future. So it's kind of the open market and the partner chain framework. It's open source and it opens all the flexibilities. And yeah, that's kind of everything gets connected. All these other options with Minitor and connecting other blockchains, it's not available yet. In the future, it's going to be available. And right now, for example, Cardano and Mita is going to be partner chain with Cardano, but other blockchains that want to become partner chains of Cardano, they can jump in, and the SPOs are going to decide what are the partner chains that they want to support by investing on infrastructure and providing that feature. Not sure if
Right.
yeah.
Yeah, I kind of I followed some of it. I didn't follow completely the part about the country, but I just wanted to. So actually, I'm more focused on Midnight versus Cardano. But I mean, I understand that Cardano SBOs can choose to accept or be block producers for other, um, you know, blockchains that accept the partner chain framework. But that's also the case with Midnight.
In the case of what do you mean in the case of Midnight? Like Midnight being having other blockchains as partner chains to Midnight? You mean?
Yeah.
Well, yeah, that could be an option, but to actually provide security and decentralization, for example, as Cardano, we sacrifice some features. For example, finality, uh, how efficient it's a blockchain in the time. For example, we can see blockchains that are really fast, they have finalities, but they have some trade-offs when it comes to security and decentralization. And in Midnight, for example, they will use a consensus that it's pretty much PBFT, but they can do that and gain all those nice features when it comes to finality and block time and all these nice features, based just because they're getting they're borrowing that security from Cardano, so they don't have to worry about all these decentralization and all these drawbacks that public blockchains with that feature they need to go through, because they're just borrowing it, and they pay for that security, and they can implement fast finality and all those features that are interested for businesses to actually have a nice block and a really aligned blockchain for businesses. So what we have in Midnight now, it's features that are aligned to create actually applications for businesses, but with the security of a public nice blockchain as Cardano. If Midnight would like to, for example, lend their security to another blockchain, yeah, they would have to create a smart contract in their ledger to actually do that. But that's something that if I'm thinking kind of like, okay, Midnight, their main feature is privacy. So we have this private ledger. In Cardano, we have public ledger. So why? Maybe it's possible, feasible in terms of the technical part, but not sure if that's something that it's in the roadmap of Midnight. It's more like the framework of partner chains and who wants to be partners of whom, right? And Midnight, it's right now it's commercialized as a partner chain to Cardano. I think for Midnight, it's gonna be really interested with Minitor to diversify their consensus by adding other blockchains as part of their partner chain frameworks, and that's it. But for Midnight to become actually the provider of trust to other blockchains on the framework of partner chains, not sure about that, Edda, but yeah, not sure if that's something that it's part of the roadmap of Midnight, but I think it could be possible, right? Maybe some difficulties in the process, because Midnight ledger, sometimes we have this private and public ledger, stuff like that.
Okay, I think I don't fully understand everything, but I I got more perspective from your answer. I'll just switch to another question that I had. I'm wondering if you are familiar, if you've seen the ZKIR specification yet.
Uh, uh, Hold on, Sergey. I was inviting Join that wanted to speak as well. Yeah, Sergey. What was your question? Sorry, I.
Yeah, no, the ZKIR specification.
Uh-huh. Yeah.
Have you seen any documentation on that?
Okay. Well, actually, yeah, that documentation is not clear yet. There's a lot of things. Midnight, it's in the process of open sourcing their instances, right? So these CKIRs are actually the way for these proof servers to create a proof, right? It's kind of the the, the procedure, right? And this is all done by the compiler. Uh, if and really there's no need to actually understand how these are made, because they're just inputs to the proof server. But if you want, what is the application actually for? Well, what is the you want to change something on the CKIR? You mean if you for what is the use case start data? Just to understand.
Well, it might be beyond my capabilities, but I like TypeScript over JavaScript, but I do actually prefer writing in a more functional style.
Mhm.
So it would be nice to be able to write in a higher level functional language and then compile down to ZKIR.
You mean you want to create a different language than compact, something like that? You want to create your own language?
If I'm capable.
Oh, oh.
But I know it's a lot to chew off.
Mhm.
It's a
No,
lot to
but
take on.
no, but Sergey, that's actually something really nice. I've seen other developers that are really interested, and that's something that I mentioned, right? We have compact language to actually write our logic using compact and then compile it, and we have this CKIR as part of their output. But actually, the language that it's understood and written within the node itself is called impact, right? That's if you see here, we have a program that it's run, but also the CKR, which is kind of the representation for the proof server. And I've seen people writing impact directly because everything when it comes to abstractions, there it has some gaps right in the middle. First, they update the latest features into Impact itself, and eventually it translates to Compact for developers to use. But for example, if you want to use Impact right away without waiting for Compact to have that feature, you're gonna have to write Impact, and in that case, you're gonna have to write the CKIR as well for your proof server to create that proof. So yeah, the use case that I see it's that if you want to start creating contracts that have the latest features that it's not available yet compact, or for example running the contract or code within the browser itself, right? So you don't depend on the compiler. So yeah, there's really nice features, and I've seen developers going that way, start Ada. So yeah, I mean, I'm not sure if it's that difficult. You just need implementation, something that you are asking. But yeah, I haven't seen that information, how to create this information based on the logic itself. Right? But it's there. I mean, for sure it's there. I think it's just closed source so far because I haven't seen that information available.
Yeah, I appreciate that, and actually, your explanation has cleared up some things for me. Because I had some confusion about the differences between impact and ZKIR, and now I understand that impact is running on the node, and um, ZKIR is the compilation target of compact that's sent to the proof server. So I mean, I think you know, I think it's a smaller surface area to compile to ZKIR, and then just instead of the whole runtime of the impact VM. But yeah, as you said, I don't. As you said, it might not. It still might be closed source.
Yeah, probably it's closed source. And Sergey, if you want to get some answers based on this, the best people to talk to would be, for example, the guys from the compiler, right? Those ones that are working with Compact, because one of their outputs is this CKIR, right? So they have the implementation. They would know where you can look at to actually understand how to create this based on impact on your code, right? So yeah, you could talk with them, and yeah, if it's open source and they are open to just give you the implementation, that would be okay. If it's closed source, yeah, we just have to wait. Okay, John, you have joined. Have any question?
I did. I wanted to touch on Starkita's first question. And so Kevin Milliken is the one who's from my understanding who's writing Compact, and I can guide you to him, Starcade. I have his handle on Discord that I can share later. So I just wanted to highlight that there's two kind of schemas going on here with Midnight and Cardano, right? Midnight is utilizing Cardano having SPOs, right? Because we have this new blockchain, Midnight, and they have no SPOs, right? So how do you implement? How do you launch when we have no SPOs? How do you launch as a decentralized entity? So they're riding on the back of Cardano, and that's their infrastructure for both security and for block production, right? And that's why you have to have a Cardano block producer to be a Midnight block producer. And then, but so this kind of if Cardano's working great and it's never been down and it's got all the security and it's very reliable, that disincentivizes Midnight from going to other places. Now we want to work with other blockchains, but there's another avenue to accomplish this, and that's calling Midnight from like Ethereum or another blockchain as an API, as a privacy layer. So it can be called, and then with Babel fees, to my understanding, one can both pay and be paid in your native token. So this disincentivizes two things. It disincentivizes other blockchains from needing to make their own privacy layer from scratch, right? Because Midnight's doing a great job, and they're riding on Cardano's safety and security. So that disincentivizes that, but there's not really a reason for them to hook up, and there's as a partner chain to Midnight. Now, Midnight, from their early documentation, they said that they had intentions of potentially being a partner chain to other blockchains as well. But obviously, if it's not a UTXO model, it's going to be problematic. But I don't know that for like in the later documentation, I don't know if that was removed or if that's no longer a thing. But I'd imagine Midnight is always going to want to expand and be interoperable. But they do have this other mechanism that you can operate and use Midnight kind of by calling it as an API from your other chain and being able to pay in and be paid in your native token. Is that all accurate, Eric?
No, perfectly, John. I mean, well summarized. And that point that you mentioned, that's really important because this option to be called API and the tokenization part to be collaborative, right? That's something really important that Midnight wants to implement. It's for blockchains not to fight between each other because at the end, based on how tokenomics works, it's every blockchain wants their users to come in, and if you join another blockchain, means you're gonna have to buy their other tokens, and there's no ways to actually create synergy between these blockchains. And by offering this option now as an API, the way Web2 works, I mean, people from a blockchain, for example, let's call it Cardano, they don't have to migrate to Midnight to actually use Midnight. Cardano applications, they can call Midnight as an API without having to go through all that friction to buy that token, because this is going to be compensated or paid by the developer itself using different mechanisms. In Cardano, we call it bubble fees. In Midnight, it's going to be kind of implemented at the ledger level, because we have this night and dust mechanism, which creates a lot of different venues and opportunities. But yeah, well said, John. And yeah, Midnight, it's open to be partners from other blockchains in the future with Minotaur. But as you well mentioned, John, right? There is no reason for Midnight to leave, because Cardano offers the best possible security available in the market, and in a good price. We don't know how much of that compensation is gonna go through Cardano, SPO, stuff like that. But at the end they have this paper and they have explained all that logic, right? And the way I see it is like in Web2, for example, putting an example as, for example, a database, an abstraction database, Convex, right? They have this dashboard that you can use their service, and you have to pay for the transactions. But if you want, you can run it, you can host it by yourself without paying to Convex. But that involves you managing the extra infrastructure and the extra security concerns. But if it's okay for you to pay that extra value for the service you receive, that's okay. If you want to break that marriage, that's okay as well. So that's what Cardano and partner chain is doing. Other blockchains are gonna be really interested on getting that service from Cardano because it's good in economics and it's good in the technical part and it's good in security. And this other blockchain, they just focus on creating this nice feature for their specific use case, for example, finality, privacy, as in Midnight. Well, I think it's been 1 hour and a half for this session. And thank you, John. Thank you, Sir Ada, for joining, and for those that are joining in the future and watching from YouTube. And we will continue on the next episode, going through this material here that we couldn't finish. We're gonna touch this the academy part. We are gonna go through the hackathons, and for the code, we are gonna now test the contracts using the testnet network. Well, see you next session. Thank you all. Bye bye.